Namaste to all, good morning. Now just this topic is in continuation with the previous topic. In the previous topic just we described how to make the representation or sketch of digital time signals and the difference between continuous time signals and digital time signals. Now we are going to have in this class what we are going to have is what operations can we make on discrete time signals. Now let us start. Now just look at in one of our previous classes, we already mentioned what type of operations can we perform on signals. The operations we can perform on signals, that is amplitude basis and time basis. These two operations we can make on signals. Here, one point you have to understand. Notice. We use the word signals. Signals means signals of two classifications are there. One is called what? Continuous, and another one is discrete. Now in the previous class, for your understanding purpose, we made operations on time-oriented operations on continuous signals only. Now in this class, we have to make all those three operations on discrete time signals too. So now just look at regarding the time means what? What operations we discussed? First operation is what? Time shifting. The second operation is called time scaling. The third operation is called time reversal. These three operations we mentioned in the previous case on continuous time signal. Now here in this case we are going to discuss these three operations on discrete time signals. For example, look at the first concept is called what? Time shifting. Now just look at here a signal will be given like this. Now just look at this is n, this is x of n. What type of signal? For example, look at this is 0, this is 1, -1, this is 2, this is -2. Just look at this is the signal given to us. From this one, they may ask us, first one, sketch the graph of x of n minus 2 or x of n plus 3. These three graphs we have to sketch from the given signal. Students have to notice here we are discussing only discrete time signals. So throughout this discussion we are using only n and x of n only. Now just look at the first one, what we are discussing, x of n minus 2. N of n minus 2. Go for the same graph first. That is 0, this is 1, 2, 3, 4, 5, 6. -1, -2, -3 like this. -3. Now try to remember in the continuous time signal what happens. Shifting can be two times. One is right side shifting, left side shifting. X of t minus t naught is called right side shifting. X of t plus t naught is left side shifting. Right side shifting makes what? Delay. Right side shifting makes what? Delay. Left side shifting makes what? The signal advances. The same concept here we have to use. Now just look at here, what is the sequence of this x of n? The sequence of x of n is equal to -2, -1, 0, 1, 2. Now this is n minus 2. N minus 2 means what? Now this is right shifting. So right shifting always makes what? It makes delay in the signal's time. Delay means what? Now just look at. Now the new width of the signal will be what? We have to add how much delay? 2 units delay. So now just we have to add 2 to these 2. So add plus 2, plus 2, plus 2, plus 2, plus 2. So what the sequence now? It becomes what? 0. Next one, 1, 2, 3, 4. Now here the amplitude is equal, for example, 2. Amplitude is 2. Now look at the previous sequence is -2, -1, 0, 1, 2. Now it is delayed by how many units? 2 units. So add 2 to each and every integer of the sequence. Now the output is what? 0, 1, 2, 3, 4. But amplitude is what? 2. Amplitude never changes. So this is amplitude 2. Now just look at, now we have to make it 0, 1, 2, 3, 4 only. Now just one. Now just look at between 2, highest one, to it reaches the highest amplitude. The remaining left side are of same height. Now the next one are same height. Last one are same height. Now just look at right shifting. By how many units? 2 units. So this graph we are writing it as x of n minus 2. This is the graph. This is right shifting. Now from this one, go for the same left shifting. Now x of n plus 3, this is called what? Left shifting. This is right shifting. Now how do we go for this one? Now just look at the same graph. We are writing on this one. So this is for n. This is for x of n. X of n. What graph we have to write? X of n plus 3 we have to write. In the previous case, x of n, what the sequence of x of n in the previous case? The previous case, x of n is equal to how much? Sequence -2, -1, 0, 1, 2. Now x of n, which one? X of n plus 3. X of n plus 3. X of n plus 3 means what? Left shift. Left shift makes what? Left shift makes advances. So now we have to add 3 to each sequence. 3, -2 plus 3, 1, -1 plus 3, 2, 0 plus 3, 3, 1 plus 3, 4, 2 plus 3, 5. So this is the width of the new signal. So now just we have to make, just look at here, the actual given signal is from, width is from -2 to 2. If it moves towards this way, it moves, no, wait. Now just look at, now this is the left side, negative shifting. Negative shifting means what? We have to subtract 3 from each number. We have to subtract 3 from each number. So now subtract 3 from 2, -5, -1, -3, -4, 0, 3, -3, 1, -2, this is -2. Now 2, this is becomes -1. Now just look at how the width of the new signal changes. Subtracting 3 from each and every number, subtracting, because it is left side shifting. This is left side shifting. Here this is right side shifting. So we add, numbers are added, plus. This is left side shifting. Left side shifting always makes what? Advances of the signal. So left side signal means what? We have to subtract a given number, given unit. How many units? 3. So we have to subtract 3 from each and every sequential value of this signal. So this becomes subtracting 3 from -2, -5, -4, -3, -2 and -1. So in this one, now just we have to make the numbers as 0, 1, 2, -1, -2, -3, -4, -5, etc., etc. So how many numbers are there? 5 numbers are there. Now amplitude how much? 2. Here also amplitude will be 2. There will be no change in the amplitude 2. Now just look at. On par with this one, now just we have to consider what integers? -5 you have to consider, -4, -3, -2, -1 we have to consider. Among them, the between one is height is equal to on par with the amplitude 2. The remaining this side and this side are of the same height. Of the same height. Next one, -1 and -5 are of the height less than that of the previous one. Now just look at. Now this is the way of representing x of which graph? X of n plus 3. Now, so this is the way. So now students have to understand same concept, whatever the concepts we used in the continuous time signal, the same concepts also we are using in the discrete time signal. But the difference is what? There is continuous, this is only discrete. Discrete means only at integers. So this is the way of using time shifting operations. So that means what? How you have to understand? If x of n is a signal, if x of n is a discrete signal, then here two ways. X of n minus some number n naught is right side signal. X of n plus n naught is a left side signal. This is called right side shifting. This is called left side shifting. Right side shifting always makes what? It makes delay. Right side shifting always makes what? It makes advances. It makes advances. Advance. So this is the way of, just look at same concept. X of t minus t naught, left side shifting, delay. X of n minus n naught, right side shifting, delay. X of t plus t naught, left side shifting, advances. X of n plus n naught, left side shifting, advances. Same concepts. Now just students have to make one more time. Easy way to understand. This is continuous, this is discrete. Continuous time signal, discrete time signal. Both are having the same principles of time shifting. This time shifting in the both cases, right hand shifting and here left side shifting. Right side shifting is also, it makes delay and left side shifting makes advance and makes advance. So this is the simple one. Look at, for continuous time signals and discrete time signals, both are same properties they are using. So time shifting is common to both continuous as well as discrete time signals. So look at, in the both cases, right side signal makes delay. In both the cases, left side signal makes advancement of the signal. This ends the topic. Thank you very much. The next topic will be continuing for the remaining time scaling and time reversal concepts of discrete time signal. Thank you.